Hello everybody, welcome to my presentation. It's my honor to be presenting you in this International Symposium on Current Research in Hydropower Technologies. So today I'm presenting on green hydrogen energy as future multidisciplinary research at Kathmandu University. My name is Biraj Singh Thapa. I am assistant professor at Department of Mechanical Engineering at Kathmandu University. I am also the faculty in charge for turbine testing lab. These are the outlines for my presentation today. So I'll start with the greenhouse gas emissions and its effect on energy and economy, and I'll try to see how the green hydrogen energy is in the global perspective. We'll talk briefly about the fundamentals of green hydrogen energy, and then we'll look towards the hydropower developments in Nepal and see the demand and supply of electricity and how hydropower can be part of the green hydrogen energy development for Nepal and the region. Then I will look towards the Kathmandu University and its engineering education programs, its success so far, and we'll try to see how green hydrogen energy can be a new multidisciplinary research at Kathmandu University. At the end, I will try to propose a multidisciplinary research center for green hydrogen energy at Kathmandu University to continue its academic and research activities in future. Energy related greenhouse emissions is accounted for two-thirds of global greenhouse gas emissions. Energy is used for all the purpose for our life to sustain. In 18th and 19th century and mostly in 20th century, a huge amount of fossil fuels were used to produce energy, and this led to greenhouse gas emissions, including carbon dioxide and other gases. If you look to the picture for how the global gas emissions and temperature rise of the earth are correlated and put the average temperature in 1950s as a benchmark of zero, then we can see the trends of increase in global gas emissions and temperature rise are very proportionate on both sides. At present, we are almost at the point of 1.2 degrees increase of Earth's surface temperature, and greenhouse gas emissions can be accounted for the most significant cause for this change in temperature, and it has a lot of consequences which I don't want to discuss at the moment. But the main aim is how can we how can we limit the rise in temperature. With the business as usual condition as a reference case, we can see that the average temperature rise will cross 3.5 degrees by the year 2100. But if we build a strong determination to bring the global gas emissions to net zero by the year 2060, then we can bring back the rise in temperature to the limit of 1.5 degrees Celsius by 2100. This needs a very strong determination. At the moment, it might look very impossible, but trying to keep the temperature change within the scale of 2 degrees compared to 2010 by the year 2000 to by the year 2100 could be possible. For this, we need to cut the global greenhouse gas emissions by 25% by the year 2030 compared to the level of 2010, and it should reach net zero by the year 2070s, close to that. So this is possible, and but there is a need of the transition to break the link between energy and economic growth to control the carbon dioxide and other greenhouse gas emissions. If you look to the link between GDP and energy rise for next few decades, we see a very different correlation from the last few decades. So rise in GDP is not contributing to the rise in total energy we consume. One of the reason is the energy systems we are using are getting efficient and more efficient. So the total energy we will be consuming, despite of rise of economy and GDP, is getting flattened. This is a good news for the emission perspective. The studies done by the Global Energy Climate Outlook shows a very clear picture that the future of the energy consumption pattern is changing, and it's changing quite a lot actually. So at the moment where we are using more than almost 90% of fossil fuels based energy equipments, the pattern is changing slowly and more drastically when we go towards 2100. Almost 80% of energy we consume will be carbon free, and 74% will be completely renewable. And that is contributing towards the control of greenhouse gas emissions, and that is necessary to limit the temperature control within the 2 degree Celsius from that what we had in 2010. So this is a share of fossil fuel used in maritime, that is the energy consumed for different purpose inside the sea. So maritime transport drives 80 to 90% of global trade, moving over 10 billion tons of containers every year across several countries in the globe. So if you see the trends as of now, so there is all the energy that we use for driving transport and other sectors in maritime is full of fossil fuels and oils, and very less of gas that is also coming from the fossil fuels. But the trends are changing. So to bring back the global temperature within the limit of 2 degrees Celsius, it is projected that the energy distribution it will be changing quite a lot. So a lot of biofuels and a lot of hydrogen fuels will be driving the maritime ships and other vehicles in the ocean in future. And it is expected, we expect this portion of the hydrogen that is using for driving the vehicles in ocean will be coming from the green sources, from the renewable sources, and this will also be similar with the other energy utility as well, other transportation sectors as well. So in overall the energy consumption pattern will change and will have to change, and hydrogen is taking a big share in that change. So this is the studies done for the projection of the hydrogen for future for until the year 2050s. We can see that the demand of hydrogen is increasing up to 10 times by 2050 compared to that what we had for 2015. So it's almost nothing uh, except the industry that is mostly producing fertilizers and others. So most of the hydrogen in for the future is is also creating new sectors like building power, industrial energy, transportation, and power generation. So not a lot of new industries are coming, and most of the hydrogen will be consumed by transportation sector. Actually, that will be the transportation sector will be the highest consumer of hydrogen energy in future, and we hope this all these new hydrogen energy and and the hydrogen energy that is still being consumed today from the fossil fuels sources, all these will be transferred from renewable sector, and that will be a very big contribution for controlling global emissions and temperature rise. So if you look towards the hydrogen as an energy carrier, it has a very basic theory, basic principle. So electricity is the background of our hydrogen as an energy carrier. So it comes in the two stages. The first one is to generate hydrogen by electrolysis of water. This is a very well-known phenomenon. Some experiments done in high school classes where we break the water into hydrogen and oxygen molecules and we can tap the hydrogen to 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 be used later on. So this is the simple reaction. So the another part of the reaction is to generate water back from the hydrogen at the utility center and producing the electricity. So the electricity which was used to break the water molecules into hydrogen and oxygen will be released when the chemical reaction occurs in the reverse direction, where hydrogen and oxygen forms back the water. So these two together makes hydrogen as the energy carrier. That is, it carries the electricity in form of the hydrogen and gives back the electricity by combining with oxygen to form the water. And this principle was invented. So this was experimentally validated by Williams Groove in 1838. So long way ago. But the commercial use was done very late. So in the modern times, the first commercially produced hydrogen fuel automobile was introduced only in the year 2013. But it is projected by 2030 that more than 15 million such hydrogen fuel based cars will be sold in the market. So it's a new and very prospective branch of innovation engineering. So why hydrogen can be considered as the future of the uh, energy carrier? If you look in the energy density, hydrogen is the lightest molecule and it can be compressed to the very high density. So it can be it can carry a huge amount of energy compared to batteries and even the best batteries. So the energy density is almost comparable with the nuclear fission. It has a less volumetric density. That means it cannot give a high amount of power in a short time, but the energy density is quite high. That means it can give a continuous power with the same amount of mass for a very long time. So if you look hydrogen as a energy carrier for electric vehicles, so this is the picture that we can see from the emerging research. So for a very small suburban cars, maybe 20 to 30 kilometers per day, very small, and motorbikes, the battery-based electric vehicles are still feasible. But when we move from the small cars to light commercial vehicles and medium to large vehicles, where we need relatively larger amount of energy before it has to be refueled, then the energy stored in battery may not be sufficient. And furthermore, battery are very heavy compared with hydrogen. So in order to transport a vehicle for a longer distance, we need a very heavy battery backups. That means that is the reason where the hydrogen fuel cell based electric vehicles seems more feasible for bit heavier cars, city buses where we have huge number of people, heavy trucks, even trains and trams, and also maybe reaching towards the airplanes and passenger ships as well. But normally at this moment, this is the area where hydrogen fuel cell seems very promising and better option than conventional electric vehicles, and also better than the fossil fuel driven normal vehicles. So this is a general layout for a hydrogen driven automobile. So we start from the tank where we store the hydrogen and the supply chain, and then this is the hydrogen is converted into electricity by merging with the oxygen from the air in the fuel cell, and the electricity drives the electric motor and produces the mechanical power. So there are some electrical converting systems for AC and DC conversion and other things, and also we need a battery backup for a start of the system in and initialize the chemical process. So it's a relatively simple system So so but the main thing is it is driven by electric motors. Hydrogen is not limited with the cars and buses only. So this is the first one of the first airplanes demonstrated for carrying the manned passengers, and it was already successfully tested in 2008. Today, lots of lots of companies are planning for developing the aircrafts powered by hydrogen and fuel cells. So this is another successful examples. The ship is called Aqua, and it has been tested up to the top speed of 17 knots, and this has the range of 3,750 nautical miles. So it seems the hydrogen technology has already crossed the stage of basic research, and it has entered into the commercial applications. The only question is how to make it more efficient, more cheaper, and more reliable in terms of safety and other things. But definitely, hydrogen will dominate the future of the transportation and other energy providing sector. So this is a comparison that has been made with the different modes of research and innovations that is happening in transportation sectors compared with the normal gasoline with the vehicles powered by hydrogen and fuel cell. So these are different types of vehicles, and this has been projected due to the innovations and engineering. It is seen that most of the vehicles by the year 2035 will come will the power of energy is comparable with the gasoline. So we can consider by the year 2035, even in the terms of energy price, the hydrogen fuel cell will be comparable to the normal fossil fuels. But when we add the value of the environment, when we add the value of the global emissions that we need to control, and when we also add the GDP that also increases the purchasing power of a normal public to buy bit higher energy sources compared to the fossil fuels, I think it is even we can compare the hydrogen driven systems with normal fossil fuels within the year of 2030. So this means the hydrogen or the green hydrogen energy will be at the center of the global economy by the year 2050 at least. The surplus hydroelectric power plant in Nepal produced by then can be profitably converted at hydrogen fuel. Nepal will have a more or surplus hydropower by then. Hence, the starting, which this is the time where we can start the production of green hydrogen energy from hydropower. That could be one of the innovative business for Nepal in the future. So let's look towards how hydropower can be used to produce the hydrogen in context of Nepal. We can call it. So Nepal is lies between the great Himalayan mountains, which is one of the huge source of hydropower development opportunities in the whole Himalayan region, and particularly in Nepal, more than 20,000 megawatts of hydropower are under some stage of development. We can see several projects are under the construction phase or under the development phase, and by the year 2030, as per the ongoing plan, almost 8,000 new power plants will be added to the grid. So this will change the energy consumption pattern. This will also change the how this energy will be utilized not only in Nepal but in the regional level. How what can be done with this energy? So this has been some projections where we can see how the hydropower uh, uh, generation capacity will Nepal will change over time. So right now we are close to 2 gigawatts or a bit below than 2 gigawatts by the year 2020. But due to the upcoming power and upcoming development of hydropower and the continuation of the trends with the government's ambitious plan, we hope that will be successful. We can see by the year 2035 we will be having almost 24 gigawatt of hydropower plant installed, and this also considers 19 almost 20 gigawatt will have some delayed of of uh, of development due to so many reasons, but still 24 megawatts will be a very high installed capacity in the year 2035. If you see the latest projections of demand of electricity by 2030, this with the several government's initiatives, the maximum electricity demand in Nepal will be around 10,000 megawatts. So this picture already shows a very high amount of surplus energy, 8,000 megawatts of surplus energy in Nepal by the year 2030. So there are a lot of discussions happening how to use this surplus energy. One of the ways is to export it to the India or in the region, and other ways is to completely change the energy utilization patterns inside Nepal. But there has to be some ways to evacuate this energy, and maybe production of the green hydrogen from electrolysis of water could be one of the ways. Due to surplus electricity, if Nepal is able to sell all the surplus electricity produced from the hydropower development, that's as per plan today. It has been reported Nepal can generate revenue of more than or almost 3 billion USD per year by the year 2030, and it can be as high as 10 billion per year in 2045 if all the hydropower can be developed as planned, and country is able to sell the electricity in somehow. This is a plan, but it has some challenges, but still it shows the possibility of selling the surplus hydroelectricity, and one of the ways is to convert it into hydrogen and sell hydrogen that may not need as difficult mode of transfer of electricity by normal uh, transmission by wires. Despite of Nepal producing huge amount of hydroelectricity, the study shows if we are not able to increase the internal electricity demand, Nepal will be using a lot of fossil fuels and fuel wood and other conventional energy sources uh, despite of huge amount of electricity it is developing inside. Only less than 6% the energy consumption will be from hydroelectricity. So rest it has to be sold. If it can be sold, we can generate a lot of revenues and the living standards and life quality for the people of Nepal. But as we depend heavily on the classical fuel methods, the study shows despite of the huge hydropower being developed in Nepal, the demand of the petroleum products will surge quite high. This is quite interesting to see that the petrol and other products, the fossil fuel products, will be still in very high demanding, reaching highest at 2050. One of the reason could be the revenues Nepal will be getting from the by selling the hydro excess of hydroelectricity will will give the people more access to the roads and more purchasing capacity to buy and own the private cars. So this could be basically by implementing the classical transportation sectors and better and higher access of the transportation sectors due to high revenue from the hydropower projects and selling electricity to the other countries. But to me, this is not a sustainable solution at all. We cannot do this to develop hydropower and to import petroleum products. But the government is also taking this matter seriously. So there are several attempts to be being practiced by government as they call combined policy scenario, where the dependency on the fossil fuel after the year 2030 will be minimized in its rate. So we can see applying different policies, government expects the dependency on hydroelectricity to rise quite high by 2030, and the dependency on the fossil fuels and fuel wood is reduced. So by the year 2050, the dependency on the electricity for the total share of the energy will be 32%. That's very good milestone, and but it needs a very careful and strategic plan and also support from the public to accept. These are some of the action plans that government of Nepal wants to implement as a combined policy in order to increase the domestic use of electricity and reduce the dependency on the fossil fuels. Among others, these fours where the electricity used for transport system has been proposed by government is quite interesting. In order to achieve the electric freight transport, electric trains intercity transport, electric cars and electric intracity transport passenger buses to be implemented and achieved these significant numbers by 2050, there should be a big change in the way we use the electric vehicles for the transport sections. And by these years, it's my it's my guess that battery-based electric systems will be phased out. The electric trains and intracity transport passenger buses needs to be fueled by hydrogen fuel cells for the driving the vehicles. So this means Nepal and the region should not only focus on how to develop its hydroelectricity, but also should be focused towards developing hydrogen as a fuel or hydrogen as an energy carrier from hydropower to these electric vehicles for future. That means producing of hydrogen directly from hydropower is one of the options, and it's not new. So this is 60 megawatt hydroelectric power plants in Norway, which was built back in 1935, and at that time it was solely used for production of hydrogen that was used for production of the fertilizers and other industrial purposes. It was destroyed in World War II, but built back in 1965. This is another hydropower plant in India constructed in 1959, and this also produces a huge number of hydrogen every year and that are used for fertilizers. At the moment, despite of higher production cost of hydrogen, these hydrogens have a high demand for the industrial scale for the high product values as fertilizer. But in future, as we need to compete the fossil fuel for the transportation sectors by hydrogen, the production cost of hydrogen that is enjoyed by the fertilizer facilities could not be feasible for electric vehicles and other transport sectors. So there is a need of academic and research. There is a need of innovations to make this hydrogen-based technology feasible, and where the research institutions like Kathmandu University comes into the role, since Nepal has a huge prospects of hydropower development and Nepal also has a huge prospects of electric cars in future probably powered by hydrogen. There needs innovations at the moment. So So I would like to investigate how Kathmandu University can take up the role for hydropower to hydrogen in context of Nepal. Kathmandu University was established in 1991. At that time, the country went through a major political change in 1990. During those days, the education programs in Nepal were more teacher-student focused on classroom and textbook oriented. So Kathmandu University took up the role to change the teaching learning methods from classroom to research based, developing the programs in mechanical engineering, electrical engineering, biotechnology, pharmacy, hydropower engineering, geomatics engineering, and chemical engineering for the first time in Nepal are some of the leadership steps Kathmandu University has already taken. Since the establishment period, KU has carried the vision to establish itself as a research based university. At this moment, I believe this is a time for KU to expand its teaching learning methods, to implement the international practices, and address the educational response of the global problems, including the need of future hydrogen based energy systems. So, for this, multidisciplinary research based learning is the future of the progressive academic institutions like KU. And initiation of multidisciplinary research in the field of green hydrogen energy with the focus of hydropower to hydrogen technology in context of Nepal and prepare the country to enter hydrogen energy could be a very good start. Kathmandu University has been acknowledged with several international awards for its um, contributions for engineering education. So it has a enough background to enter into the future of multidisciplinary research based education and for this country and maybe for the region as well. Conducting research and education activities in the theme of green hydrogen energy needs a multidisciplinary research team, and that needs a team from different groups, including environmental science engineering, chemical engineering, mechanical engineering, and electrical and electronics engineering. Each research team in the each department or subdivision can contribute to the research for the green hydrogen energy for the different kinds of activities. Department of Mechanical Engineering itself has four subdivisions with the energy technology, hydropower, design manufacturing, and automobiles that can take up the role from the fundamental research to the end use for of the green hydrogen energy. And other schools and other departments can also contribute for the different aspect of the green hydrogen energy. So I see a strong possibility and also opportunity for these subgroups and departments to develop small research team for hydrogen energy in each group and integrate these research group as a multidisciplinary research unit, maybe called as green hydrogen energy, or also this can be developed further to take up a specific center or a research center as center for green hydrogen energy. I propose these as the way forward for Kathmandu University to use the hydropower to produce hydrogen and and utilize it for different aspect including transportation sector for in context of Nepal. That will be a very good contribution for Nepal in future. So with this, I would like to propose a research center for green hydrogen energy at KU. So this can be a multidisciplinary research unit with the state of art facilities, as Nepal and Himalayan region has a very high hydropower potential. The specific research focused on green hydropower, green hydrogen energy, or particularly hydropower to hydrogen energy technology for the region can be a specific topic for this center of research. There is a need to identify the prospect of hydropower to hydrogen technology in the Nepalese context and transfer the relevant knowledge in the Himalayan region. The fundamental and applied research conducted in this center can lay the foundation for the commercial application of hydropower to hydrogen technology in Nepal and the regions. And also the academic engagements and research will produce capable and competent human resources which will be required for the future development of the projects in future. So some of the initiations has already been taken. So these are the two examples that Department of Mechanical Engineering has already initiated. So this is a project proposal submitted to University Grant Commission to start the green hydrogen energy research in Nepal at Kathmandu University Department of Mechanical Engineering for the 2 years duration period. So the concept of Center for Green Hydrogen Energy is also started in the Department of Mechanical Engineering. The concept proposal has been developed and it is under the discussion. Since this is a multidisciplinary research, since this is the future uh, research topic between the different departments, different the schools, a big discussion is necessary at the university level. And I hope one day or in recent future this research will be institutionalized in at Kathmandu University, and Nepal will and the region will be benefited. Thank you very much for your time. If you have any questions, you can directly write to me. It will be very good to discuss with you, to collaborate with you, and to contribute towards hydropower to hydrogen energy or green hydrogen energy for future. Thank you very much.